Hello and welcome to this video on volume. So in this video we're going to be looking at how to calculate the volume of 3D shapes, and then we're going to be looking at how to apply these skills using some past paper questions. So first of all then, what is volume? So volume is the amount of space taken up by a 3D shape, and it's measured by the number of 1 by 1 by 1 cubes that fit inside the shape. As you can see in this nice little image of a cuboid here. Okay, so when we're doing the volume of cubes and cuboids, it's nice and straightforward. We've got a nice little animation here as well that shows you this. So we take the width and we multiply it by the length, and then we multiply it by the height. And you can see with this example here, we've got a cuboid that's 3 centimeters by 4 centimeters by 5 centimeters. So if we multiply those numbers together, we will get 60 centimeters cubed. And this nice little animation of this cuboid here shows this nicely, because we can see that this shape does have 60 cubes that form it. So always remember, width times length times height will give you the volume of a cube or a cuboid. So for the next question then, I would like to work out the volume of this cuboid. So pause your video and have a go. And here is your correct answer for this. So always remember with cubes and with any volume, it's always measured in centimeters cubed, meters cubed, or millimeters cubed, depending on the units of measure you are given. So you do need a little 3 on that at the end, on your unit of measure at the end there. Okay, here's your next one. So for this one then, we've got 5 times 13 times 8, and that will give you 520 centimeters cubed. Okay, so if we take a look at the volume of some other prisms then, so just so you're sure what a prism is a 3D shape with 2 ends that are similar. So on this example here, we've got a triangular prism. We can see we've got this end here that's a triangle, and you've got the exact same triangle at the other end. So it looks a little bit like a Toblerone if you have eaten one of those before. So when we're trying to calculate the volume of one of these, you need to work out the area of the cross section. So that's this triangular end here. So remember, with triangles, it's always base times height divided by 2. So what's happened here is we've done 4 times 5 to get 20, and then we've halved that to get 10. And then all we've got to do is multiply it by the length of that prism. So the length here is 9. So we've done 10 times 9. And our volume on this example is 90 millimeters cubed. So just to recap, with prisms, it's always the area of the cross section multiplied by the length. And you will be given this formula during the 2024 series of papers on the formula sheet. You are going to get a formula sheet for this year only, but if you are studying beyond that, you may not get that formula. Okay, so I'd like you to work out the volume of this triangular prism then. Okay, so if we do the area of this triangular cross section, we've got half times 11 times 8, which will give you 44 centimeters squared for the area there. Or you could look at that as 11 times 8 divided by 2 if you like. And then all we've got to do is multiply that by 7, and that will give us 308 centimeters cubed. So your next one then, we've got this cylinder this time. So if we do pi times 6 squared, that will tell us the area of this circle on the cylinder. And I've rounded that to 1 decimal place here, so you'll get 113.1 centimeters squared. We've then just got to multiply that by 23, and that will give us our volume, which is 2601.3 centimeters cubed. Okay, so let's have a little look at some past paper questions here. So we've got a bit of a mixture. Some are taken from Edexcel papers, and some are taken from AQA papers. This first one then, so Bob has got a van. He delivers boxes in his van. Each box that he delivers is 60 centimeters by 30 centimeters by 40 centimeters. The van has the space for boxes in the shape of a cuboid with a length of 3 meters, 1.8 meters and 2 meters. You need to work out how many boxes can fit into this van. Okay, and here is your solution to this question. So what's happened here is we've turned these measurements for the van into centimeters, and we've looked at the length. So 300 divided by 60 will give you 5. So there's 5 that's going to go lengthways. 180 divided by 30 is 6, so you're going to get 6 going that way. 200 divided by 40 is 5, so you're going to get 5 going that way. And you've then got to multiply these 3 numbers together, and that will give you 150 boxes. You could have done this another way. You could have turned the measurements for the boxes into meters if you want to. So you would have had 0.4 meters, 0.6 meters and 0.3 meters, and then you could have used those numbers to do your divides as well. But it doesn't matter which way you've done it as long as you get to 150. Right, next one then, we've got a diagram showing an empty water container. Fiona's going to use a bucket to fill the container. Each bucket holds 12 litres of water. So we want to know how many buckets of water will be needed to fill this container. And you've got this measurement here to help you. So 1 litre is 1,000 centimetres cubed, and they will usually give you that on questions like this. Okay, let's have a look at the solution to this. So if we do the volume of this cuboid by doing 90 times 50 times 40, that will give you 180,000 centimetres cubed. If we divide that by 1,000, that tells you the container holds 180 litres. And then if we do 180 divided by 12, that tells you you're going to need 15 buckets to fill the container. Right, final example then. This time we've got a cylinder. It's got a radius of 40, a depth of 150, and it's being filled at a rate of 0.2 litres per second. And again, you're told that 1 litre is 1,000 centimetres cubed. So the question this time says, does it take longer than 1 hour to fill the tank? So if you pause your video and have a go, and make sure you definitely use a calculator for this one, because the sums are quite tricky for this particular question. Okay, the first step then is to do pi times 40 squared times 150. So this part here will give you the area of the circle on top of the cylinder. If you times it by 150, that will give you its volume. So you've got 753,982 centimeters cubed. If we divide that by 1,000, that will turn that into liters. So we've got 753.982 liters. If we then divide that by 0.2, you'll get 3,769.91 seconds. And remember that in every minute, there's 60 seconds. So if we divide that by 60, we'll get 62.831 minutes. So then the answer would be yes, it takes longer than 1 hour, because remember that 1 hour is equal to 60 minutes. So I think this question was at 4 mark question, this one, 4 or 5 marks. So there's quite a few steps involved, but it was definitely on a calculator paper. So don't worry, you're not going to have to do anything this complicated on paper 1. Okay, so thanks very much for listening, and bye bye for now.